Okay, we're going to go through the steps to drawing images in a plane mirror one more time. So if you're not sure how to do it, just kind of follow along one more time. The first thing obviously we got to do is start with our scientific drawing of a mirror, and we have to draw a simple image. So the simplest image is a straight line, and we can label those 2 points A and B. Okay. Now, to find our image in the mirror, we have to start by first drawing an incident ray from point A to the mirror at a 90-degree angle. So there it is. There's our incident ray showing our 90-degree angle. Now, once we've done that, the law of reflection states that at any angle of incidence, it's going to come out at the same angle of reflection. Because it's 90 degrees, our reflected ray would come out exactly on top of our incident ray. So that's the first step. So now that we have that drawn, we have to draw another incident ray. This incident ray can go at any other angle to the mirror other than the 90 degrees. So for our example, here's our second incident ray. Now again, at this point, this is another point of incidence. We are going to draw a normal. Okay, so a normal again is 90 degrees to the surface of the mirror from the point of incidence, at the point of incidence. Once we have our normal drawn, we can then take our protractor and line it up on the mirror and on the 90 degrees, and then we can measure our angle. So in this case, it looks like 10, 20, 30, 40. It looks like 40 degrees. Okay, now our law of reflection states, there's 40 degrees, sort of. A law of reflection states that the angle of incident is always equal to the angle of reflection. So now that we have our protractor here and we've measured our angle of incident, what we can do is then draw a reflected ray, because we will measure our new angle, our angle of reflection, to equal 40 degrees, and then draw our reflected ray. So there it is. Now our reflected ray obviously goes away from the normal. Okay, so now that we have our two incident rays are coming from point A, we're going to move on to step 3. Now what we're going to do is for each of the reflected rays, so here's, I drew the reflected rays in a thicker pen, we are going to extend them behind the mirror. And the reason why we're extending them is if we look at these reflected rays, this one's going off in this direction and this one's coming straight down, they are never going to intersect on this side of the mirror, on this plane. They're kind of actually moving away from each other. And anytime we have rays moving away from each other, we extend the rays behind the mirror. Okay, so for each of these reflected rays, you're going to draw a dashed line that extends behind the mirror. So there's the first one extended behind the mirror, and there's the second one extended behind the mirror. Now, you'll notice that they intersect. So at this point where they intersect, we get to label that point A prime. So this is the original point A, and this is point A of our image. Now to find the rest of the image, what we're going to do is we're going to repeat those steps, but we're going to repeat them for point B. So I've kind of grayed out what we've just done because there's going to be a lot of lines up here. So we're going to start again. Step 1, you're not going to see the instructions this time, but I'm just going to kind of walk you through it. Step 1 is we draw that incident ray at 90 degrees to the surface through point B, because we're trying to find point B this time. And we're going to reflect that ray back at 90 degrees, because the angle of incident always equals the angle of reflection. For step 2, we're going to draw that incident ray anywhere else to the mirror, and at that point of incident, we're going to draw a normal. And then again, we're going to line up our protractor on the normal and the mirror, and we're going to measure that angle of incidence. And it looks like 10, 20, it looks like this time it's about 30 degrees. Okay, and because we've measured that angle, we can then measure our angle the other way and get our angle of reflection and draw, there it is, and draw our reflected ray. Last but not least, again, because these rays are both going away from each other, right? They're moving apart from each other on this plane, we are going to reflect or extend the rays behind the mirror by drawing dashed lines. So there's the first one extended behind, and here's the second reflected ray extended behind as well. Last but not least, where they intersect, we are going to label that point, and because we were finding point B on this side, we label it as B prime. So now that we have all the lines drawn and I've kind of grayed them out, just focusing on our two points that we found for our image, we get to connect them. And again, instead of using a solid line, because our solid line is our original objects, we are going to connect those image dots with a dashed line. So that this would be our object, and now we've found our image located in the mirror. Now, don't forget about salt. We've found the image, which is 50% of the battle, but we still have to describe those image properties, right? Its size, its attitude, its location, and the type of image. So in this case here, we're dealing with a plane mirror. We can see that the size is the same. We can see that the attitude is upright, even though it's kind of been horizontally flipped here or inverted. We can see that it is the same distance away, and because it is upright, this is a virtual image. So those are the steps again to finding images in plane mirrors.